Let's rewind to 2014, when Java 8 was released and the way we process collections changed forever. Before streams, developers relied on clunky for loops and nested if statements, making code harder to read and maintain. With the introduction of streams, backend development entered a new era. Suddenly, transforming data, aggregating analytics, and building real-time dashboards became more efficient and expressive. In today's world of Spring Boot microservices, streams are everywhere, powering millions of requests daily. This video explores the 4 hardest Java 8 stream questions I faced in senior interviews and how mastering them can elevate your backend thinking. My current role as an architect for Spring Boot microservices, streams are a daily tool. We use them to transform API responses, aggregate analytics from Kafka, filter database results, group transaction data, and build dashboards. Streams have become the backbone of scalable, maintainable backend systems. Their versatility allows developers to write concise, readable code that handles complex data transformation. This foundational shift means that understanding streams is no longer optional for senior Java developers. It's essential for building robust, high-performance systems. Over the course of more than 50 interviews for senior Java roles, I noticed a clear pattern. While most developers are comfortable with basic stream operations like filter and map, only a small percentage can explain advanced concepts such as lazy evaluation, custom collectors, or safe parallel stream usage. Top tech companies focus on these advanced questions because they reveal a candidate's depth in functional programming, performance optimization, and production-level thinking. Mastering these topics sets you apart from those who simply copy code. Streams aren't just a new syntax, they represent a shift in how we approach data processing in Java. By enabling functional-style operations on collections, streams allow for more declarative and concise code. This not only improves readability but also opens the door to powerful optimizations like lazy evaluation and parallel processing. For senior developers, understanding streams is crucial for writing scalable, maintainable, and high-performance applications. The following scenes will break down the 4 hardest stream questions and the thinking behind them. Most developers are familiar with the basic stream operations like filter and map. These methods allow you to process collections in a functional style, filtering elements based on conditions or transforming them into new forms. While these basics are essential, they only scratch the surface of what streams can do. In interviews, you'll often be asked to go beyond these methods and demonstrate a deeper understanding of the stream API. One of the most misunderstood aspects of streams is lazy evaluation. Unlike traditional loops, streams don't process data immediately. Instead, operations like filter and map are only executed when a terminal operation such as collect or forEach is called. This allows streams to optimize processing, skipping unnecessary steps and improving performance. Understanding lazy evaluation is key for writing efficient stream-based code and is a frequent topic in senior interviews. Custom collectors are a powerful feature of the Stream API, allowing you to define exactly how elements are accumulated into a result. While the standard collectors like toList and toSet cover many use cases, interviews often test your ability to write custom collectors for specialized aggregation logic. This requires a solid understanding of the collector interface and how to handle mutable reductions safely and efficiently. Parallel streams enable concurrent processing of data, potentially improving performance for large collections. However, using parallel streams safely requires careful consideration. Issues like shared mutable state, thread safety, and performance bottlenecks can arise if not handled properly. Interviewers often ask about scenarios where parallel streams are appropriate and how to avoid common pitfalls. First tough question I faced was about lazy evaluation. Interviewers wanted to know if I understood when stream operations are actually executed. The answer lies in the distinction between intermediate and terminal operations. Intermediate operations like filter and map are lazy. They don't process data until a terminal operation is called. This allows for optimizations such as short-circuiting and skipping unnecessary computation. Second challenging question focused on writing a custom collector. This tests your ability to go beyond the standard collectors and implement complex aggregation logic. You need to understand the collector interface, including its supplier, accumulator, combiner, and finisher methods. Demonstrating this knowledge shows you can handle advanced data processing scenarios in production code. Third question was about using parallel streams safely. While parallel streams can improve performance, they introduce challenges like thread safety and shared mutable state. Interviewers want to see if you can identify when parallel streams are appropriate and how to avoid common pitfalls, such as race conditions or performance overhead from excessive thread creation. Fourth question explored the design of complex stream pipelines. Interviewers often present a real-world scenario and ask you to build a pipeline that chains multiple operations, such as filtering, mapping, grouping, and collecting. This tests your ability to think functionally and design efficient, readable data processing flows. Mastering streams requires a solid foundation in functional programming concepts. This includes understanding immutability, pure functions, and stateless operations. Interviewers look for candidates who can apply these principles to write clean, maintainable code that leverages the full power of streams. Streams offer many performance benefits, but they also come with trade-offs. Understanding when to use sequential versus parallel streams, how to minimize unnecessary computations, and how to profile stream pipelines is crucial for senior developers. Interviewers often probe your awareness of these performance considerations. Senior developers are expected to think beyond code correctness. Production thinking means considering maintainability, scalability, and reliability. When using streams, this includes handling exceptions, ensuring thread safety, and writing tests for stream pipelines. Interviewers value candidates who demonstrate this holistic approach. Even experienced developers can fall into common traps when using streams. These include accidentally introducing side effects, misusing parallel streams, or misunderstanding how collectors work. Being aware of these pitfalls and knowing how to avoid them is a sign of a mature Java developer. Streams are used in a variety of backend scenarios. From transforming API responses to aggregating analytics and filtering database results, streams provide a flexible and powerful way to process data. Understanding these use cases helps you apply streams effectively in real-world projects. One advanced stream operation is grouping and partitioning data. Using collectors like grouping by and partitioning by, you can organize data into meaningful structures. This is especially useful for reporting, analytics, and building dashboards. Interviewers may ask you to implement these patterns in code. Streams play a key role in building real-time dashboards. By processing and aggregating data on the fly, streams enable developers to present up-to-date information to users. This requires efficient pipeline design and an understanding of how to handle large volumes of data in real time. In modern backend systems, integrating Java streams with Kafka is common for processing analytics data. Streams can be used to aggregate, filter, and transform messages from Kafka topics, enabling powerful real-time analytics solutions. Interviewers may ask about your experience with such integrations. Streams are often used to filter database query results. By applying filter and other operations, you can refine large datasets efficiently. This approach is especially useful in microservices that need to process and present only relevant data to clients. Grouping transaction data is a common use case for streams. By using grouping by and custom collectors, you can organize transactions by user, date, or category. This is essential for building financial dashboards and analytics tools. Designing efficient stream pipelines is both an art and a science. You need to balance readability, performance, and maintainability. This involves choosing the right operations, minimizing stateful transformations, and ensuring that pipelines are easy to test and debug. Testing is crucial for any production code, and stream pipelines are no exception. Writing unit tests for stream operations ensures correctness and helps catch edge cases early. Interviewers may ask how you approach testing complex stream pipelines. Handling exceptions in stream pipelines can be tricky. Since streams favor functional style, you need to find ways to manage checked and unchecked exceptions without cluttering your code. Interviewers may present scenarios where robust exception handling is required. Immutability is a core principle of functional programming and streams. By avoiding mutable state, you reduce bugs and make your code easier to reason about. Interviewers often ask how you ensure immutability when working with streams, especially in concurrent scenarios. Since Java 8, the Stream API has continued to evolve, adding new methods and optimizations. Staying up to date with these changes is important for senior developers. Interviewers may ask about your familiarity with recent enhancements and how you leverage them in your projects. Following industry leaders and reading expert articles can deepen your understanding of streams. Many top engineers share their insights on platforms like Medium, offering practical tips and advanced techniques. Continuous learning is key to mastering streams and staying competitive in interviews. Mastering Java 8 streams can open doors to new career opportunities. Senior roles often require deep knowledge of functional programming and stream-based data processing. By honing these skills, you position yourself for growth in backend development and leadership roles. Summary: Java 8 streams have transformed backend development, making data processing more efficient and expressive. Mastering advanced stream concepts like lazy evaluation, custom collectors, and parallel processing sets you apart in senior interviews. By understanding these topics and applying them in real-world scenarios, you can build scalable, maintainable systems and accelerate your career growth.